showed that the runtime is like 1 gig large. After that 1 gig is downloaded, you're good to go. Now, of course, I've set this up such that you're expecting a number much smaller for the web stack, right? That was intentional. I practiced that in the mirror. So how big is the actual runtime stack in practice? So here's the size for that legacy web stack, which I showed you from a couple slides ago, right? In other words, if a page wants to run in this sort of backwards compatible mode, this is what it would have to include, right? And so this graph up here shows the size of the compressed ASTs that are actually sent over the wire. So for example, the HTML parser was about 280K, and the JavaScript runtime was about 200K. And so note that the average web page today is about 1.6 megs in size. So if the browser has a totally cold cache, Atlantis makes the page roughly 47% better. However, as I mentioned, this is sort of a worst case number because typically the cache is warm.
How did you make the parsers at the runtime?
How did I make them?
Yeah.
Oh, so
like take chromes and translate to them to an AST, or did you write them?
That's one thing that you could do. No, I did it from first principles by looking at the spec. But there are tools which allow you to, for example, take C++ code, like Inscription you may have heard of, or things like this, and then compile it down to JavaScript. So that's one option we decided not to take because, as it turns out, that tool chain is fairly fragile, and we wanted to avoid some of that over there.
You mentioned WebKit.
Yeah.
WebKit takes about 4 hours to compile.
Yeah.
And it's a bit bigger.
Yeah.
What happens if you actually want to use WebKit?
Well, so you're saying, what if I actually want to use the full-blown sort of WebKit with all its gnarly features? I mean, you could do that. I mean, there's nothing that prevents you from